All right, how's everybody doing tonight? If you could do the steps on the whiteboard there, that would be great. That's going to be your beginning of your lab, because the rest of the lab you're taking home, but the beginning part of the lab you're going to get with each other and get each other's email address and a time to set up to do the lab remotely, because it's a remote lab. All right, quickly I want to go over first though, schedule. We're on week 8 right now. 3 weeks from tonight, 3 Thursdays from tonight, we're not meeting that night. That's a research night for your final paper. There's no face-to-face class that night. Please use this time to begin or continue to work on your research paper and presentation. That'll be creeping up pretty quick. Research paper presentation, remember, is in lieu of a final for this class. And everybody submitted a topic the first few weeks in class. In week 10, the week before you actually have your research night, I'll kind of help you and go over a PowerPoint template with you, some structuring helps maybe for your research paper, and how to convert that to a PowerPoint or a presentation. There's other type of presentations to make besides PowerPoint. You got Prezi out now, PRZI.com, which is a popular one that people use. It's a 3D rendering PowerPoint presentation online, basically. And then you got open source apps you can use, like OpenOffice, to create PowerPoints. And so we'll go over those on week 10. So just a few more weeks before you have research night, and then just 3-4 more weeks after that. Actually, I think it's week 14. Week 14, we begin presenting the presentations. And order of presentations, we're going to have submitting them in here, A's through N in week 14, everyone else in week 15. And so it's going to be creeping up pretty quick, so just to kind of heads up. And then this week, week 8, chapter 7, quiz and review questions as always. And we're going to talk about WAN and remote connectivity tonight as it pertains to what we're doing in the lab this week, and actually next week we're going to be doing remote lab, where you'll be remoting into each other's computers outside of class using remote software. One of the softwares I mentioned last week, I'll mention again, is logmein.com, which is a free website, free service, kind of like Find My PC, a number of other ones that are free or that are paid. This one's actually free to use, and so I recommend it, logmein.com, for home use and business use to log into servers and such. But this chapter goes over different topologies as it refers to WANs, okay? So far we've talked only with wired bound networks. Tonight, this week, we're beginning talking about unwired bound networks, meaning through the internet, through Wi-Fi, through other connectivity devices, T1, T3, T2 connections. And so there's other topologies that are just like the local, like the star, bus, ring topologies, hybrid topologies, but they apply to WAN, and anything that's WAN is over the web and over the internet. And there's different topologies that we'll go over here and some of the methods. So the word WAN basically is how a network traverses across from one place to the next. And anything when you refer to WAN, you hear of anything that says WAN in any readings, online, books, it always refers to the internet, always refers to the cloud, always refers to something connected outside of a building. Transmission medium depends upon the business needs, and we'll look at some of those transmission mediums for WAN technologies. There's some common properties between WAN and LANs. You have your client host property, layer 3 protocol, packet switching. Just like tonight, as I'm presenting, I'm using an actual web service called mysyncpad.com that's actually putting the screen of my iPad through a WAN app using this. This would be the client, my iPad, and the host would be the mysyncpad.com, where it's hosting that screen. And so as things are happening on my screen, they're also happening on the overhead. And so I can, everything I do on here basically being mimicked onto that using WAN topology. There are differences in WAN and LAN. One would be layer 1 and layer 2 access. All this is referring to is the wiring, okay? The wiring. Right now when you connect to the network in here, you have a Cat5 connection through a NIC card. WAN topologies uses different connections. We'll talk about those. There's different topology differences there, different media access. So LAN wiring for the most part is private that we use in here in this classroom, and in most businesses it's all private. At home it's a private network. When you're on your Wi-Fi router at home, it's a private network. It's only for you. Okay, only for your computers can communicate to that router. WAN topologies, on the other hand, are public, and they have network service providers throughout. Okay, AT&T would be a public WAN provider. Okay, as just an example. T-Mobile, Verizon also has other WAN. You might have heard of some Clear Mobile, Clear Communications, out of Chicago, where you can get a radius of, say, 75 miles from the inner city of Chicago. Anywhere you can get access to this service using satellite and point-to-point technology, getting WAN connection that way, versus what we're used to getting around here, which is cabling into the house, right? But if you live in the inner city of Chicago, you don't have to have cabling coming into your house. You can actually walk around with your laptop, iPad, or wherever, anywhere in the city, and have connection and pay for a service every month for that connection. Okay, it's live all the time, anywhere you go. And so again, that's WAN topologies, be able to do that. As far as the complexities, it's just taking a small segment like we've learned so far to create a small LAN and making it larger. And so the complexities are, we're used to on the left side in a building or in a buildings, the right side is connecting cities to one another, city to city, complex to one another using a WAN topology. So you'll notice the structure is the same, technology is the same, it's just how it's applied and what media it goes across. So a WAN site is going to be geographic in location. A WAN link is WAN to WAN, okay? And generally there are going to be dedicated lines. Like say Pepsi is an example. I used to work for them going through school. They have direct lines from each plant to the mothership, to the location of the corporate office. A direct T1 line runs directly from that location to the mothership, to the home office. And you'll see a lot of places do that. Here on campus, we have a direct line, a T3 line from here to Springfield, Illinois, where we get our internet connection. Direct line, literally a direct line all the way. Now granted it goes from different paths and stuff, but it's literally a line that goes all the way in a T3 connection. $1.5 million a year for a grant just for that we have somebody hired just to do that, just to put the money for that. It's pretty expensive. But WAN topologies, differences in LAN is covered, of distance covered. Okay, number of users, distance traveled. The sites connected are going to be usually a high-speed internet, hopefully. And they also require routers in a WAN connection, which on a local LAN you don't have to have that. You can get by with dummy hubs like we've used in here to connect a LAN. Using a crossover cable to connect peer-to-peer. Well, in a WAN you have to have routers. Okay, and we did a lab a few weeks back on the. We talked about the tracer route. The tracer route, when you do that on a environment, it hits routers throughout your pings when you're seeing those come through. That uses WAN topologies, like Google.com is an example. Multiple servers throughout the nation. If you were to ping Google.com or do a tracer, it's going to hit multiple routers before it gets back to you. Okay, and so the routers are definitely a requirement on this, and it's not capable of non-routable protocols like here in the classroom. We can do 10.1 numbers. You can't use those Class A's, the non-routable IP address ranges, in a WAN environment. You can only use Class B and Class C ranges. Bus topology. Each site connects 2 sites maximum serially. So for every site, you have 2 sites connected, similar to the LAN topology on the site dependency. The network site dependent on each other to transmit the data. Difference from the LAN though, in the different locations connected to the other through point-to-point links. That point-to-point links could be radio wavelengths. It could be satellite, just to name a couple. Or it could be direct line T1, fiber. Best use for bus would be organizations requiring a very small WAN, dedicated circuits, drawback, not scalable. Downtown Rockford has multiple bus topologies going on between building to building. Have you ever heard of Rockford Internet before? Rockford Internet has multiple sites set up like this in downtown Rockford where 3 or 4 businesses will share the cost for internet, but between the buildings they have a point-to-point, basically satellite pointed to each other, point-to-point radio connection, radio wave connection, pointing to each building, giving each other connection. Okay, and that's real popular. In metropolitan areas, it's real popular because, you know, it's cheaper for businesses to do that, and you still get the bandwidth and you still get the throughput, but it's not going to cost as much if you pull it together. So the buildings could be something like this, basically, where you've got maybe 3 or 4 buildings on a block or blocks connected one to the other. This one shows connected via DSL and T1 lines, but it could also be radio wave point-to-point connections as well. The nice thing about using a satellite dish type of connection, a radio wave dish like we have out here on campus, the dish farm, is you don't have to run wires. You just point-to-point to each other on top of the buildings. And you have to, you have to structure the dish to where it's pointed, so it takes some setup there. There is some maintenance on it, but much cheaper than what you're seeing here with the T1 direct line to building. Okay, and so this is a popular way to set up a bus. Ring topology is the next one. Ring topologies, each site is connected to 2 other sites, forming a ring pattern. Similar to the LAN in the fact that it connects different locations. It does rely on redundant rings. And remember, on a ring topology, what it needs for, just like on a LAN environment, you've got 3 points that are connected. For that transfer to happen on a ring environment, for me to send, for this computer here, to send something to this computer, basically in a ring environment, you're going to have, I'll put another circle in here, 3 at a time carrying the data all at once, the same data. It's redundant on purpose to make sure the data gets to maybe this location. And so on ring topologies, you've got the computer sending it or the server sending it and 2 other components sending that same data for that to work. It is redundant, and the purpose of redundancy for this one is to make sure the data gets there without fail. And best use for this is connecting 4 or 5 locations maximum. Banks use this a lot, banking facilities in metropolitan areas that have the main bank, like say Chase, and 4 or 5 subsidiary banks within a 10-mile radius will use this topology. Okay? It is very expensive, very secure, and you also make sure the data, it gets there, but it's expensive. Okay? Very expensive. And on this one, basically, it's connecting all of them together. Unlike the bus, it's just one-to-one. Here you'll notice it's entire ring of the entire connection of buildings that you have in that environment. So if we had 10 buildings, they would all be connected to each other in a ring environment. The star, the star topology is actually the most popular because it's the newest and actually cheapest to set up. It mimics a LAN. It's a single site central location, separate data routes between the 2 sites. Advantages on this is single connection of failure affects only 1 location. So on a LAN environment, you've got, again, your central location, which we'll say is, maybe, Pepsi corporate or something. Then you got multiple subsidiaries out here. Each one of these, though, are connected back to somehow the corporate office. But if one of them fails, the rest of them are still up and going on a star topology. Not the same in ring or bus. If one fails, specifically in ring, the data is going to fail and the link's going to fail. So star topology is going to be definitely advantage there. Shorter data paths between any two sites when all dedicated circuits are functioning. Expansion is very simple. You just add another line to that location, whatever line you're using, maybe T1, DSL, fiber, whatever you're using. Drawback, central site failure, which would be this one right here. Central site failure, if that one goes, the whole system's down. But that's the only drawback to it. And we have that in all environments today in networking, because most networks are set up mainly on the star topology. So if Google's main servers are down, the whole website's down. Okay, AT&T, same thing, Comcast, whatever, it's going to be down. So here we have a building serving as the main structure in the network, giving T1 connection between the buildings. So if that building failed in its capacity or in its network, the other three wouldn't get connection. But if one of the buildings failed, just that building's out and the other two are fine. Then we've got the mesh, which basically incorporates all of them together. And basically it's taking all of them, and you've got possibly on a mesh you could have a conglomerate. But for this one, the routers play a big part in it, because the routers can redirect data easily in a mesh environment. It uses other routes that it might not own to get the data there in the mesh environment. Okay, it's the most fault tolerant of all WAN type connections. There's a full mesh WAN, which every WAN site is directly connected to the other site. The drawback to this is a cost on this one for a full mesh WAN. The partial mesh WAN is that not every site's connected to each other on a partial mesh. And you might have, in that case, it borrowing other channels and other ways of connecting to that site. Those other channels could be VPN. Those other channels could be remote desktop, like we're going to be using this week, to connect to a site. So here we have a mesh and a partial mesh. A full mesh, you'll notice, not only are the buildings each connected to each other, but you have the crisscross in between that also connects them one to the other. So you've got the outside connection, that's T1 here, and then DSL connecting in between for this full mesh. So basically you have redundancy and connection on a full mesh scenario. Pretty expensive, but if you need data there, if one type goes down, so say if you have the T1 go down, you might still be able to rely upon the DSL, which by the way, the T1 is going to be much faster than the DSL. So in this scenario, the DSL would probably be a backup type of connection. So if one failed, the other one's still up. This one, a partial mesh, you'll notice Detroit and Dubuque are pretty well set for the most part, but look at the Indianapolis route. It's out there by itself, not connected to anyone else but Dubuque. So that would probably be the weakest link there out of all of them, but it still works. Then we've got, you might have heard of this one. This happened in the 90s, ISDN. ISDN was one of the first types of WAN topologies that businesses grabbed onto, because that was the first one available. Came up in the 90s, connected WAN locations for voice and data. And protocols were physical, data link layer, transport layer on the OSI. You had signaling, framing, connection setup, termination. This was right after the dial-up age started. So it was the same topology or same technology as dial-up, but faster. It relied on the PSTN for transmission medium. And basically dial-up or dedicated connections were the first ones that relied upon this digital transmission. And the closer you were to the corporate, the faster you had the connection, the closer you were.
Or to the telephone switch.
To the telephone switch, right.
I actually set one of those up.
Yeah.
Back in the day.
Yep.
And it was on demand, so it wasn't connected all the time.
Exactly, right, as you needed
So
it.
you would call out to the internet, then it would make a phone call or whatever.
Yep, to connect you.
Yeah.
Yep, yeah, that was pretty popular back then.
Way more affordable than the T1.
Yes, way more affordable. ISDN, the types here is single line, which is simultaneously 2 phone calls or 2 voice calls and 1 data connection. There was at this time, though, a lot of congestion because as people started using more data, the voice would sometimes drop in the connections. Then there was 2 channels that came in. One was a bare channel, the other was a data channel. The B is a bare channel that used for circuit switching for voice, video, audio, a whopping 64 kilobits per second on this one. The D channel is a data channel that used 16 to 64 kilobits per second. And the 2 rate connections they had was a basic and a primary. The basic rate was a low-end rate, and the primary rate was just a little bit faster. Then we get into the T lines like we have here on campus. T1, T2, T3 carrier lines. They are a physical layer operation of the OSI. They have a single channel divided into multiple channels, and they run over a 2-pair wire system. Like we did the 4-pair wire, this is a 2-pair wire system. That's T1, T2, T3. The medium, telephone wire, fiber optic, wireless links, use these. T1 runs on any of these. Telephone wire, the regular analog telephone wire, fiber optic, and wireless. The fastest and most efficient, you can probably guess the fiber will be the fastest, most proficient connection. But when they are setting up T connections in areas, they will use whatever they currently have set up in that area, that region. So if they already have analog signal, analog wires, which most buildings do if they're older, they'll use those connections in the building for the T1. And then maybe have a fiber drop within a block or 2 from that site to pick it up from there to go wherever the corporate drop is. And then wireless links, that's a newer one for T carriers, wireless links is. And wireless links is something that's fairly new, still kind of experimental for T1 through T3 connection. When you get into the T, though, you'll notice the throughput. Let's look at that, the throughput column. Depending on your signal, depends upon the throughput that you have, all the way up to the D55 signal layer has up to 400 megabits per second, static, upload, and download both, all the time. That would be a more expensive, that's a T5. We have a T3 connection here on campus. The good thing about T3 as you get up higher is the number of channels you can have. Each one of those channels can be a separate type of node for, say, voice, data, and, well, those 2, just voice and data that they can connect it to. And also you can split them up into different types of networks on your environment. The most common is T1 and T3, and we have T3 here on campus. A little bit more expensive. The types of carriers here, to explain them in detail. T1 has 24 voice and data channels, a maximum data throughput of 1.544 megabits per second. T3 has 672 voice and data channels, maximum throughput of 44.736 megabits per second. T carrier speed is dependent on the signal level that it's on, which is the physical level of the OSI inside of the T. It has electrical signals, it is digital, and 1 voice and 1 channel would be a DSO. I think we have like around a DS40 or 45 or something like that here. T1 uses are for branch offices, connecting carriers, telephone companies, ISPs, all use T1s. Like GoDaddy, would be an example of a T1 carrier. T3 would be data insensitive. Well, it might be data insensitive too. Data sensitive, meaning that environment is pushing data all the time, pretty much 24/7. Educational facilities will have this a lot. T3 though provides 8 times more throughput. That's why the $1.5 million price tag, by the way, on T3 connection. You can have multiple T1s that can accommodate the needs, basically making it like a T3 by having like 3 T1s connected, evidently. T1 though costs vary per region. There is what's called fractional T1, where businesses can co-op, kind of like we talked about earlier on the building-to-building connection. They can co-op them to have a fractional T1 lease and charge accordingly. You can even charge by usage as well. The T carrier requires connectivity hardware on the customer site, on the switching facility. You can have purchased or leased hardware. It cannot be used with any other WAN transmission. And the T-line requires different medium. The T-line requires different medium. Internet connection pooped out here. My internet pooped out. I was talking about internet connection. Let's switch over to that instead of waiting on that. My internet broke, for me anyway. I don't know if it is everywhere, but it is for me. All right, but I've got a backup. Always have a backup. You guys might be fine, it might just hit me. There you go. All right, so you have a T-line carrier connection, needs hardware, as we mentioned before the internet broke on me. You have your customer site, you purchased, can be purchased or leased, and T-line carrier requires a different medium to travel upon, different media to travel upon. And generally that media, by the way, is fiber on a T-line carrier line. Wiring can be plain telephone wire, UDP or SDP copper wire. We used RJ45 jacks. Your home lines use RJ12 jacks for regular phone line jacks. It uses that fine. You can also use coaxial cable, microwave, fiber optic cable. T1s use STP they use STP, require repeater every 6,000 feet. And you have multiple T1 lines, have coaxial cable, can be microwave as well, fiber optic. T3s require microwave and fiber optic. That's why we have the microwave satellites out here when we do use them for connectivity to point to other locations to give a talk or to set up a video conference. It uses those microwaves because T3 requires them as well. We use mainly on campus microwave from point to point, and then fiber from building to building within the Rockford region. Here's what the jack looks like. It's mounted to the inside of a building, generally, in the basement area or foundation area. And the terminator wires come in, and they can be inside or outside. Generally, you'll find these inside a building, like in a closet or inside of a basement or something. And then they have a connection monitoring port also on this one to where you can connect it to a server to monitor the connection and the speed. There is also a CSU and a DSU, channel service unit and data service unit, two separate devices. These combined into a single standalone device. They have an interface card much like a NIC card, and most of them, since they use fiber, have a fiber NIC card built in. And they're at the T1 line location point is at the customer site, and most fiber is ran underground. If it's new lines ran, they run them underground or dug underground and placed in like a PVC type of pipe. And then the CSU, the channel service unit, provides digital signal termination and ensures connection integrity. So basically what you're looking at here for T1 is basically what you guys have at home for your cable connection, but about 100 times more technical than the one used for cable, and 100 times faster connection-wise that can be used for a T-carrier connection. Here's a DSU, CSU connection terminal that basically does have a little LCD screen there on the left side that can tell such things like IP address, uptime, collisions, things like that can show up in there. And on the front of this ports here, basically for the most part, these are all going to be fiber connections. So you've got basically your smart jack, which again is built on the building's internal wall somewhere generally. And then the multiplexer can be within that same area, generally like within say 100, 150 feet. Or I've even seen these multiplexers blocks away from that location in a box for other businesses that connect to this multiplexer as well. So you've got basically your incoming and you got your outgoing. The incoming, the multiplexer separates the channels and where it's going, basically what jack it's going to be going to within that region, because it could be multiple buildings it's going from the multiplexer to the smart jack. And then outgoing reverses that logic and it goes to the proper multiplexer in that location. T-carriers also have, as LANs do and WANs do, switches, routers, bridges. Bridges basically are just devices that connect your routers and switches together and bridge them together. The best option though is a router layer 3 or a higher switch. These do accept CSU and DSU signals from a T-carrier. They also translate on the network layer data to the destination. CSU and DSUs may be integrated with the router and switch. They do have an expansion card, kind of like your NIC card we did last week, that can be put in the device. Faster signals processing, better performance. They're cheaper and lower maintenance for these type. So here we have the cloud. T-carrier comes through the cloud to the smart jack. From there, internally connected to a router within the location, within the building. And then from there, spread throughout the location, meaning data and telephone. The telephone would be like a voice over IP connection, maybe like a 3Com or an Intel, or Cisco even has phones now for that. Then DSL, digital subscriber line. This operates over PSTN as well, directly competes with ISDN and T1, requires repeaters for long distances. It's best suited for a WAN local loop. So what that means is, like with the neighborhoods, cities is where you'll see this used at. Supports multiple data, voice channels, can be ran over a single line. It can be ran generally over telephone lines. Use advanced data modularization techniques. If you have DSL, or if you've had DSL before, you might have remembered you had to have a filter connected to your phone line. Anybody had DSL before? You had to have a filter connected to your phone line, and what that would do is filter out the connection that DSL, the analog connection that DSL did not need, the static. It basically would block out that static for the connection to come through for your internet to work properly. But modularization is used to alter the signal. So if it's running across an analog line, it goes through the modem and alters that into a digital signal to go to your computer and modem. Because as it's going across the analog line, it's analog. The demodulator or your DSL modem basically converts it to digital. All right? Converts that analog to digital. Now, if you remember, I remember we had DSL when we first got it. I did not have a connection. I thought, oh, it'll work without this. We don't need to filter. No biggie. I'm not going to do it. And I was on the phone, or my wife was on the phone, and my kids were connecting to the internet, and my wife's connection was dropped immediately. She was talking on the phone with somebody and was pooped out. So I drug out the filter, the DSL filter, plugged it in. Worked great. I guess you do need it. And so there's a reason to have the DSL filter on the line for those analog signals to be filtered out. XDSL refers to all DSL varieties. You got ADSL, G-Lite, HDSL, SDSL, VDSL, SHDSL, asymmetrical and symmetrical categories. The downstream and upstream, the benefit of DSL is it's got a more static stream in my mind, as far as it might not be faster or fastest in the world as as cable is, that we'll look at in a second. But as far as for web developers, they actually tend to like DSL a little bit better than cable modems, because the up speed, which most people at home don't use upload much, but if you're a web developer using it all the time, it's going to be a much more static speed, and a lot of times faster speed than you get on broadband connection. Downstream and upstream throughput rates they differ depending on your connection. If it's asymmetrical, you get more throughput in one direction, like downstream throughput higher than upstream. Best use for this one would be video conferencing and web surfing, which most end users use at home, right? That's what people do. The later, symmetrical, it's more for upstreaming. It does have downstreaming as well, but examples for this is HDSL, SDSL, and SHDSL. Best use for this is uploading, and downloading is significant data amounts. So this one actually is good for both high volume uploading and downloading. And you generally have to pay more for that service. Okay? Pay more for the more uploading and downloading bandwidth. So if you look here on the, let's first look at the maximum upstream, we'll look at that. We'll start out at the ADSL, the full rate, 0.640 megabits per second, all the way to the VDSL, 1.6, 3.2, and 6.4 megabits per second, maximum upstream. Then maximum downstream, you have from 6.144 on ADSL full rate to the VDSL of 12.9, 25.9, and 51.8 megabits per second. And then the distance feet between drops is 18,000 for ADSL and 1,000 to 4,500 for the VDSL. And generally, if in this technology, if you had a lot of users in your area using it, it degraded significantly your throughput. Okay? And so they would have to a lot of times add in more drops in those regions, but they generally drag their feet and would take a long time for that to happen. And so if you had a lot of users in your same area using AT&T DSL, your servers were degraded from somebody maybe in a newer subdivision that just got it, and maybe just have a very few users around them using it. That makes sense? And so the fewer users you had, the faster throughput you had, regardless of what connection you had, what type of connection you had. So it varies on data modularization on DSL, capacity, distance limitations, and the PSTN use. PSTN use, basically, when they refer to anything PSTN, that's how close you are, how close you are to that drop in that area for that connection. Here's a Netgear DSL modem, very common one. Establishes a connection, transmits the DSL modem, internal or external. The splitter separates the incoming voice and data stream, may connect from there to a other hub, switch, router, and real popular, Netgear was. ADSL, DSL modems, what they do is they modulate, and they modulate the signal coming through a 4-pair UTP wire, untwisted pair wire. The distance is less than 18,000 feet. Signal combined with other modulating signals on a telephone switch. And what this is talking about is the drops in the area. And that fits well in residential, which is the most popular for DSL. Carrier's remote switching facility. The splitter separates the data signal from the voice. The request is made from a DSL multiplexer, and it's issued from the carrier's network to the internet backbone to do all the switching. So you basically got that splitter there in the middle. Underneath the internet, you've got the splitter. From the splitter is where it's split in from the PSTN, from the provider, in a drop box location somewhere in that area, somewhere in that region. And then it's split over wires, telephone poles. Most of these are not ran underground in most residential areas. Anything that's ran underground today would be fiber that comes to that. They're not going to spend money to run these underground. And then the splitters are actually also found on telephone poles to split that signal to different houses in that block. And they're generally found splitters are generally found in alleyways, in between houses, in the middle is where you'll find them at. Around the same area where you'll see the telephone boxes, the analog telephone boxes, the ComEd boxes, around the same areas is where they'll all be. Competition for DSL, now I don't think it's much of a competition because businesses aren't going to mess with DSL much, but anyway, the book says it's T1, ISDN, broadband. I can see broadband being definitely a competition with DSL. DSL installation, fairly simple. You generally have some type of hardware where you can purchase it yourself, that modem, or the provider like AT&T will charge you like Comcast does to buy that device or to rent that device from them. And then DSL drawbacks, not available in all areas. Upstream throughput is lower than broadband cable. That used to not be the case. Used to, like I said, when this first came out, upstream was the benefit of DSL over any other transmission at that time. In fact, when DSL first came out, the only other transmission you had prior to that was dial-up. And so it was very, very popular. But now today, cable has upped its ante on the upstream. Cable companies is the next one. Broadband, which, we might as well just say Comcast. That's it. That's all we got. They own everything. They even own security now. They own security. Somebody emailed me about that. I don't know if one of you guys did. But, they're actually in the home security now. They actually own a home security company. But cable companies connect now through cable. They offer cable, Comcast being the major one, based on the signal. TV signals, coaxial wiring. The theoretical transmission, 150 megabits per second downstream, 10 megabits upstream. Real transmission, 10 megabits downstream, 2 megabits upstream. The transmission can be throttled and limited by the provider. And also shared physical connections can also limit the downstream and upstream. So when you're connecting at home or in a business, the more connections you have to that cable modem, the more degraded that download and upstreams are going to be. Okay? So if you have one connection, it's going to be much faster than one connection than say 20 people connected to that same connection. Right? Just math and science, math basically, mathematical.
Does that mean within the household, or do you mean like in the block of your neighborhood?
No, within your household. Within your household. Because generally Comcast can actually limit it per household. They do throttle it per household. Now, that's not to say though, there's times of the day where you're going to have faster download speeds than others at your house because of congestion in Comcast in general in your area. Okay? And so you are going to have congestion because of that. Best use for this, web surfing and data downloading. There's a Linksys modem, which many of you might have, or Netgear is another one, 3Com. Requires a cable modem to do this, modulator and demodulators built in. Has reception of signals via the cable wiring. Operates on the physical and data link layer of the OSI model. And it may connect to other connectivity devices like a wireless router, which many of you do, to name one example. The infrastructure for this coming into the building or the complex is going to be what's called hybrid fiber coax. And basically it's expensive fiber optic link supporting high frequency data. It connects a cable company like Comcast office to the node in that area. Okay, and that node is generally going to be a box, like a metal box, mounted to a telephone pole with multiple connections. It's generally locked, multiple connections. And the cable drop connects the node to the customer's business or resident through fiber optic or coaxial. It connects to the head end of the cable drop, meaning where it's actually coming into the wire, into the box is where it connects. It provides a dedicated connection, and many subscribers share the same local line. They also share the same throughput. That's why I mentioned earlier, your data can be degraded, upload and download depending on the day. Like 3 in the morning, much quicker to download and upload stuff than say 3 in the afternoon. All right? And that goes without saying in any area, any region. So basically you do have what's called distribution hubs throughout the rings that determine the drops where they're at, where they're located at. The drops basically are repeaters throughout the region, in this case residential areas, and the more drops you have on one distribution hub, the more degradation you're going to have on upload and download speeds. Does that make sense? The more drops you have. So if you have a drop area and you have 100 people connected to that drop area versus another area has a drop area of 20 people, the 20 people are going to have a much faster connection, upload and download speed than the 100 because they're sharing the same line. Both sets are sharing the same throughput coming down. Because I have heard students complain like they pay more for throughput possibly for faster downloads and faster uploads, and they're not getting it. And a lot of times it's the nature of the beast with as many connections as they have, that's probably all they're going to get. But Comcast won't tell you that. They'll just say, well, we'll keep working on it until you finally just say, forget it. I'm going to drop down to the basic rate or whatever because it's not going to happen. So here's just a screenshot of the different WAN topologies compared from speed. I just want to highlight a couple here that we went over. Okay, we got dial-up all the way to dial-up. Anybody, how many people in here have never used dial-up? Never used dial-up in your whole life? Be honest now. I know there's some of you. Never used it. Okay. Well, dial-up is by the wayside, but you know, believe it or not, there's still people that use it.
There's still companies out there.
Still companies that use it.
Net Zero or something.
Net Zero's one. Yep. Do what now?
My parents.
Yeah, my grandfather had that, yes. Yeah, in rural areas, it works fine. Well, as fine as dial-up can work. So you got dial-up that's a whopping 56 kilobytes per second. Actual, 53 kilobytes per second. To T1, 1.544 megabits per second. And that one can use microwave fiber cable all the way to T3 like we use here, 54 megabits per second, microwave fiber. Broadband cable like you guys use at home, 10 megabits per second upstream, upstream. And downstream, anywhere from 256 to 276 kilobits per second downstream. And some of you are probably getting faster now, I'm guessing. Through the SONET and the ATM. The SONET one basically is fiber optic only WAN topology. So fiber is throughout from the company, the corporate office, to the business is fiber.
Is that the kind of fiber optic when you're talking about putting on through?
Yeah, and they are new residentials, but the existing, it'll be years before we see it. Well, the big one that AT&T has been promoting is the what is it? Somebody help me. It's not. It's internet, but not internet. TV. What is it?
Uverse.
Thank you. Uverse. They've been promoting that, and they do have it in some regions, not in the Rockford region, but like in Chicago, subdivisions, newer subdivisions.
My sister-in-law in the Chisholm Park just got fiber from AT&T, I think.
Oh, they did.
Yeah.
Okay. Well, again.
But what is it? I don't know. They're telling her it's fiber. Whether it really is or not is another question.
Well, they might, because I've heard there are outlying regions that are getting it, and so. But Rockford will probably be the last one that gets it. Even though if it's a new subdivision, it's all fiber for sure. But they can offer it in certain areas, and I've heard they're going to do that on the east side. But I'm glad you said that, because the last I heard it was going to be within a 20-mile radius of Rockford, another probably 5 years.
She lives up off of Roseville.
Okay, cool. That's great. Well, that'll be really good, because that'll be competition for Comcast. And anything that's competition for Comcast is good in my mind. And so I don't like Comcast.
Neither. They always try to rip you off.
They don't try, they do. So there's no bones about it. That's what they do. Now let's talk about remote access, which you guys are going to be doing tonight in just a second. Remote connectivity. How many has used or you currently use remote connectivity maybe at work or at home, anywhere? Or you have maybe in the past you've used it? Okay, cool. So about half of you have used remote connectivity. This has become popular in the last 2 or 3 years because companies now can hire people actually to work from home. That's been a big one, right? Working from home, it's a huge thing now, a huge trend. Because if you think about it, you don't have to pay for a cubicle, you don't have to pay for the heat, the air, door access, whatever else they provide, lights, furniture. I mean, it's thousands of dollars a year probably. They don't have to do all that. And you can work from home and get access. My son works for a company in Rockford, and he lives in Springfield, Missouri. He actually started in Rockford, but when he moved to Springfield, they let him move he took a Magic Jack actually with him. He's using it already at home. Took a Magic Jack until they actually set him up. He actually has a 3-com phone now. But initially it was just a Magic Jack connection. And he connected to the corporate office in Rockford and has worked there for now over 2 years now remotely. And he manages 5 people in Rockford, even though he lives in Springfield, Missouri. And so remote access is huge right now in networking. Network admins will use this, and if you've not used it, you will use it if you go into networking all the time, okay? Whether you're remoting clients in another building, in that building, or in another region, you're going to be using remote connectivity. It's basically a service-allowing client connection, logging on to capability in a LAN or WAN environment. So you can use services like VNC, software like VNC that's open source to locally connect to clients, or software like I mentioned, like logmein.com, which you can log into any computer and any that's the client's installed on anywhere in the world from any web browser and connect to it. So you got remote client, which accesses the files, applications, and shared resources as if they were right there in that location, sitting there, okay? And I did a demo for you guys last week on mine, connecting to a PC across town. Remote access, communicate requirements. You have a client, host transmission path. Generally, the host transmission path is going to be the web. It's going to be the internet. Whatever internet connection you have is going to be your path that you're on. It could be Wi-Fi, it could be cable, it could be, you name it. That path could be it, whatever you're connected to. Then appropriate software. They all have appropriate software that's needed somewhere in the communication. Like on LogMeIn, you have to install LogMeIn on that server or PC or Mac that you're wanting to connect to. Now, when you're outside of that environment, to connect to that computer or server, you just have to have a web browser, and then you log in, and then you're connected to that machine and sitting right in front of it. You also have to have a dial-up network, possibly if you're connecting to Microsoft's remote access server, which isn't really popular anymore, but the book mentions it. Also VPN. VPNs, for the most part, use today anyway, whatever connection you're currently on, whatever connection you're sitting at, whether it be a hotel, whether it be Wi-Fi, whether it be wired, wireless, doesn't matter. And then dial-up networking, which again, most of you don't use anymore, but there might be some locations where they still use it. We just killed our dial-up connection here on campus, I think last semester. There was still some faculty dialing up because we offered internet connection. Faculty could dial up through a dial-up modem, connect to our connection modem here on campus, and then get internet connection at no cost. But it's like, dirt slow, basically. But they finally killed that off. But there might be still some locations that have this, but it's just dialing directly into the location, like I just mentioned, like we did here on campus, into the private network or ISP's remote server, logging onto the network, getting file access and all the good stuff. And then the transmission methods for this one is ISDN, PSTN, or X25, which basically is all analog, except for the ISDN. Analog dial-up. Advantages of dial-up is well understood, been around a long time. Disadvantages, throughput, as you can imagine, quality of service, the screens, that thing that's going on. Administrative maintenance, that's one of the things why we killed it. We had to upgrade a modem or something where it's like, are you serious? There's 2 people using it. It's dead. We're putting an axe on it. And then Microsoft software, again, remote access service, routing and remote access service are still part of the OS in Windows 7 and server, but nobody uses it. Literally hardly anyone uses it anymore. It's built into Windows, though, but you can use it, just nobody does use it. Server requirements for remote access servers are basically, you got to be able to accept the clients as they come in, that be granted the right access to get in, usually a port opened up. If you're using software-based remote programs, they already built all this stuff into the software. Device types, you got dedicated devices like Cisco's AS5800 access servers, also computers installed with special software like logmein.com, like go to mypc.com, just to name a couple. And then Microsoft remote access software. The routing and remote access service, computer accepts multiple remote connections at once, server acts as a router, and multiple security provisions. Again, that one just never really hit off. I played with it some, but I didn't like it. So here we have clients connecting with a remote access server. Could be anywhere in the world. You got DSL, you got T1, you got broadband. The guy in broadband could be at a cafe in London. The guy in T1 could be at a in a desert in Arizona. The DSL guy could be, I don't know, in Disney World in Florida or something. All connected to the same location, same building, okay? and getting their files and getting their programs to get their work done. So you're basically connecting to that local LAN through a remote access connection. Does that make sense? And that's how you're getting your work done. It works on the OSI model on these layers here, the application layer, transport, uses TCP, network IP, data PPP, and physical layer, the Ethernet. All right? And PPP OE, PPP over Internet standard, basically all it does on this standard, and it's on the data link layer, is it connects home computers to the ISP through DSL modem or your broadband connection, or even maybe if you're from Chicago area, the one I mentioned earlier, the Clearcom mobile connection. The computer client controls everything basically, like I said, like you were sitting right in front of it, across the network connection. It's dedicated WAN link, internet connection, dial-up, works, all of these. Establishes directly between the client and host modem. The host allows the clients to come in. The username of the computer and password are passed through as if you were typing it right in the keyboard there in front of the computer, because you are. And then thin clients, this is another way virtual computing software requires little bandwidth. And this is generally going to be done, and businesses are actually starting to do this. We could say you guys are all on thin clients, right? And you work for me, and but our server that pushes the software to your thin clients is located in Georgia. So when you log in, when you come in the morning and you see the login screen on your computer, it's not on your computer. It's just on your monitor, but everything's literally in Georgia. The actual software and the operating system's pushing it to your screen to see it on your screen. And you really only need a dummy terminal. You just need a computer, a keyboard, mouse, monitor, and a little black box to connect your peripherals, and that's it. Everything else is pushed through a thin client location. And that's a real popular one too, low cost too, because every dummy area, the computer, keyboard, mouse might cost maybe 30, 40 bucks if you shop them in bulk for the entire, because the monitor is not going to be anything fancy. It's not going to be a fancy smancy monitor. You know, it's just going to be a dummy terminal basically to get the work done. And I think I mentioned maybe last week, if I did, you know, like Sears, JCPenney's, they've used this actually for years, this thin client that I'm mentioning. Because, you know, any updates need to be done, they do it on the server because it pushes out to the clients, the thin clients. Advantage of remote computing, very simple configuration. If you've not used it, you're going to use it tonight. We're going to start using it tonight and talk about it, and we'll play with it a little bit, show you how it works. It can run on any connection type. There's a single host, except multiple connections from multiple clients. And remote virtual computing software. Differences on this one is capabilities and platforms. There might be some platforms it doesn't work upon, and security. Examples of this remote virtual computer: Microsoft Remote Desktop you might have heard of, VNC you probably heard of, Citrix you probably heard of, just to name a few popular softwares that are out there. The remote desktop protocol, which is a Windows protocol, works on the application layer, uses TCP/IP. It's generally existed for Windows computers in a local domain, a local area network only. Okay, not to connect across regions, but within buildings. So if I'm wanting to connect to my Windows server using this remote desktop, it works pretty good. It works fine for what it does. But if I'm wanting to connect at home to my server, I'm not going to use this. I'll probably use another service like you know, go to my PC or logmein.com service, which would be much easier to set up, much more cost effective for companies to set up and to manage as well. But all your computers have the system properties. If you didn't know it already, when you go to the right click on computer, go to properties, there's a remote tab, and you just basically allow users to connect remotely to that computer. And by default, that's unchecked. That has to be checked in order to be able to use Windows desktop remote to connect to it. That's what it looks like there. When this comes up, you just type in the IP address of the computer on the network. You hit connect, and then you authenticate with your username and password as if you were, again, sitting in front of that computer. And if it's turned on to allow you to come in, you get in. If it's not turned on, it says can't connect. Yes?
What if they're using DHCP?
Doesn't matter.
So how do you know what the IP address is for that?
You'd have to know it.
So you have to go and figure out what it is?
Yep. Yeah, you'd have to know it. Yeah, you'd have to ping it or, you know, do an IP config on that server to figure it out. It also does use DNS as well, so you can type in the name of the computer or server. So I could type in cconcle if that's the name of my computer, and it would figure it out on the network and pull it up. VNC is another popular one. This is really probably more popular than Microsoft. It's open source. Anyone can download it and install it. They come two protocols on this, a server and a viewer. The server is just that, it runs on constantly in the background all the time. And then I can go to another computer, fire up the viewer, the VNC viewer, type in the IP address, and then there's two ways you can connect using VNC. I can type in just a password, just a one password connection, and it lets the user in to that machine just with one password. You don't have to type in a username and password, just a password, and you can get in. Now, that's not to say if you had VNC on a server and it was logged off, say it was logged off on that server, and you used VNC Viewer to get to that server, and you saw the login screen, you'd still have to log in like you normally would on that server to get in. So if someone was to get the IP address of a server that had VNC on it, they would still see the login screen of the server and not be able to go any further unless they knew the username and password. Advantage of this is multiple computer platforms, Mac, PC, Linux. It's open source. It's a whole bunch of different flavors out there. For Ultra VNC is probably the most popular. You can just Google Ultra VNC and download that. Chicken of the Sea VNC for Macs is real popular. But Macs, in the last couple iterations of releases, now their own built-in remote connectivity software, so they don't really use it much. Which, by the way, that is built on VNC as well. The drawback, there is some flickering. It's it's free. Okay, it's not like real flashy or anything, and it's kind of, like I said, flickery on the screens, but you can get your job done, and I've used it before. Then you've got some other independent computing architecture. This means anything but Microsoft and VNC, which is open source. So you got Citrix would be one. It's proprietary software. Another one might be would be logme.com would fit into this one as well. Go to my PC would fit in this one as well. Advantages, it's easy to use, broad compatibility. Disadvantages, high cost of Citrix products. Citrix actually is pretty expensive because Citrix is a little different and what we're mentioning with LogMeIn and go to my PC. On Citrix, you actually install the service on a server, a Citrix server, and then as people log into that Citrix server, they have different sessions per user that's created. And then that user from that session can connect to their files, not necessarily their computer screen, just network files, if that makes sense. Okay, they can connect to network files. Basically, when you connect to a Citrix server, you still have everything you normally have on your computer, whatever it is you're connecting on, but you now have drive access to all work stuff. Does that make sense? So you're not, it's different than go to my PC and log me in, which is you go to your actual computer that you work on every day. Citrix, you just connect to the network to have the drives and access to the drives. Yeah?
Citrix tends to be more of a corporate solution.
It is definitely a corporate solution, yeah.
Where they're either, corporate companies I've worked for that have used it or looked into it, it's a question of, we don't want to have to install or configure a server on site because we don't have the expertise in-house.
Exactly.
We'll pay them to just run it for us.
That's what they do.
Their server.
Yep,
So,
yep. Yeah, that's what it is. It's a corporate entity, and it's higher cost.
It's almost like a.
But there's certain,
terminal, really.
it is definitely that. And you have to have your own dedicated server to do it, or servers. So, you know, it's a cost effective, but it is secure. It is updated. It is, you know, you have your product support and all that good stuff. And so that's why companies buy it. You know, you got your return of investment for sure, especially if you're using it with 100 plus sales associates all the time. It's, you know, it's good. There's nothing wrong with it.
Can you comment a little bit on like the go-to-my-PC?
I will.
Types as far as security?
Yep, when I get to that area, I'll definitely will, because we're going to be ending on that one. VPNs is the other. This one's used amongst multiple networks, different types of networks. It can be isolated from other public traffic, and it is isolated from other public traffic. It's actually basically like a wrapper. So basically you've got your connection here, whatever that connection might be. We'll say it's, you know, cable connection. And when you connect to VPN at work, it's a wrapper that puts around that connection for security, encryption, those two main things, security and encryption, around that communication to get to that location, to get to that connection. It's inexpensive on the software, sometimes included with other widely tailored software. Log Me In and Go to My PC is a software-based VPN. It is a wrapper around whatever connection you're connected to. And so it is very secure and much cheaper for individuals to purchase. So here we have a VPN connected to custom offices all around the nation. Notice the cloud, meaning wherever they're at, they connect to it. And again, VPN connections generally have, Cisco has VPN connection clients. That's probably the most popular, where you literally set it up on the laptop. They double click on a icon, and then they log in with the username and password, and they're connected to their network at work, wherever that might be. VPN, point-to-point technology. Again, Microsoft developed this initially. It's been picked up by other technologies now, other companies like Cisco, which they call theirs L2TP, Layer 2 Tunneling Protocol. It connects VPN using equipment mix. Again, money. So anytime you think of equipment, it's more money for the company. So not only does Cisco use their own software, but you also have to buy their unique proprietary hardware to do this. And it works, and it is secure. But again, more of a corporate, probably more corporate definitely in its slant. It can connect two routers together and then tunnels those with what's called packet switching on the network with a tunneling effect like I drew here. Basically, it has a tunneling effect which gives the security and encryption. Okay, and that's it. So let's talk about the last two, which is going to be, well, actually three. Log Me In, I mentioned already. Go to My PC. And the one you're using tonight. You should have a PDF I had you download for that one. This one right here, which is a Team Viewer. That's the third one. Okay. Security-wise, all three of these are just as secure as any of the other protocols we talked about through Cisco, Citrix, you name it. Okay? But they're marketed and tailored more for consumer level. The reason for that is, the reason businesses don't use it as much is a lot of IT departments do not want anyone just setting up any type of remote anything on any computer. Okay? Does that make sense? And so, not that it wouldn't work, it could work, definitely it would work. But if you set up any of these that I mentioned up here on your local PC at work, your IT department might not want you to do that, okay? Because they want you to use their corporate way to get in, number one. Number two, it's one point of entrance using, say, a Citrix server versus 150 or 200 points of entrance using these types of softwares on every client. Does that make sense? So it's not that it wouldn't work or couldn't work, it's just a matter of management, pure management, of managing 150 installs of LogMeIn or GoToMyPC or TeamViewer on every machine versus a Citrix solution, which is one server. It's locked up in a server room and only IT can access it to do any updates or management. Does that make sense? So it's more of that, why this isn't as popular in the corporate world. But that's not to say you can't use this, and it's not used in IT, because it is. IT admins use these all the time. We use these, LogMeIn for sure. I've used this for years in the server environment to log in, even though maybe corporately we don't allow it to be used on the clients. We use them to connect to the servers if we want to, outside of the environment, because it works great, and it's a cheap solution, and it's.
Is that what you would use to if your server's in a data center somewhere, typically?
Oh yeah, definitely. Yeah, LogMeIn gives you initially 5 free, but then you can get a corporate account, which you can get unlimited connections that way, and you can set up a. They actually have a new service on LogMeIn.com called Rescue. That basically, say you're in a help desk type of environment and your client needs help and they're in the field, they go and usually have an icon on their desktop, double click on it, they give you a code and you enter in that code, the IT person does, for a one-time connection to go in and fix something. That's the new service they provided now. It does cost, but you have your own login and access and everything for it. GoToMyPC is a lot like LogMeIn in that, and I've tried GoToMyPC. I like LogMeIn better because it gives you 5 free initially. GoToMyPC, you can get a trial, but then initially you have to pay after that trial's over. There is nothing free for you to use. And so I always tell students to do this one for sure. Not that the GoToMyPC is not good, because it is, but it does cost. LogMeIn tends to lean more towards technical folks like yourself and networking admins, and they have a lot of cool software in there to do that and to play with. TeamViewer, the one we're going to be using tonight, is also a popular one that's propped up the last 2 or 3 years. A lot of IT departments are using this as well, because you can actually put this on your desktop. You'll find out when you guys do this lab together. You put it on the desktop of every computer on your location. When you need help, you call IT, you start up this application, and you tell IT what your code is to get in, and they get in, and then they fix whatever issues it is that they're having. And then once you disconnect, you're disconnected. You don't have to, you're not connected all. They can't just log in anytime on your machine. Yeah.
So is it like using the programs and then like the remote host that's built into like ICP? Is it like the features and then?
Yeah, the features would be, the features are definitely the benefit. Like I said, the remote desktop on Microsoft works. It works fine on an internal environment. So if I don't have LogMeIn on a server or VNC on a server, I can use the remote desktop, okay? But a couple things have to be occurred, and sometimes you don't want this turned on for security purposes. Hackers can actually, and they will try to remote into a server using remote desktop. Well, if that check mark is checked, meaning they can get in and try to hack a password possibly. If it's unchecked, they're not going to be able to even access that using a remote desktop. Now, if I have VNC installed or LogMeIn installed or whatever, or GoToMyPC installed or even TeamViewer, they have to be able to know a couple things about that, what I'm using to be able to connect to it first, like a code. You can do like code access, password access, a whole bunch of cool stuff. It is a little bit more secure because of that, yeah, definitely. And so out of these 3, the 2 I recommend, we're using one tonight. LogMeIn.com is good for this purposes where I use it all the time. Connecting to your stuff that you work with every day. That stuff could be servers, your PCs and Mac clients. So your stuff is what logme.com is going to be used for. Okay, stuff you work on every day, all the time. TeamViewer and go to my PC would be there as well, but I recommend this one. TeamViewer is used more for one-time access, even though they added a new feature to do what logme.com does now, and it does work well, by the way. I've actually been playing with it. Meaning, when you set this up at home, you have an option to set this up all the time to be used, or just a one-time access. You have two options to play with. If it's a one-time, it's one time. You double-click on the executable, give the person that's going to help you an access code and password. They fire up TeamViewer on their side, type in your access code and password. They get in and begin doing whatever work you need. It does have a chat feature in there where you can chat with each other on a chat feature. But then when the user's through helping you, or you disconnect them, one of the two, that session's done. It's a one-time session for accessing computers. So it's great for help desk, helping your family possibly, helping your neighbors in a one-time access type of environment. Now family, I actually did the top one. I had logged me in on my mom's computer because I would do monthly updates on her computer and stuff for her. And so, family members, more than likely, if they need your help, it'd be easier to use this than to have to spend all of your vacation working on their computers, right? And so you can do this before you leave to make sure everything's good and ready to go. So let's talk about TeamViewer real quick, and then we'll be done. Okay, TeamViewer, what you're going to do is, and when you guys get home, you're going to connect and download the TeamViewer file. Once you download it and you go to install it and accept the agreement and everything, this is an important part right here on this step 4. You want to make sure and select install or start without installation, okay? And it's just a one-time selection then. You'll click next, and then notice you get an ID and a password, and you're ready to go. And so to set up a remote connection, all you need to do is tonight before you leave, you're going to set up a date and time with somebody around you to connect to their PC or Mac. It works with Mac or PC, by the way. Decide who's going to be the expert remoting the computer, remoting your computer, or vice versa, you remoting their computer, and who's going to be the user being controlled. So to begin the session, you're going to, and both by the way, are going to do steps 2 and 6 above. Make sure you do 2 and steps above we just went over, which is the installation part. But both of you start TeamViewer. The user will call the expert or email, however you guys want to do it, or text, give them the ID and password. The expert will use that ID and password to connect to the partner. There will be a prompt for the password you have to type in. I think initially you just type in the ID, then you'll be prompted for the password. Once you're connected, the expert will start Notepad or TextPad if it's a Mac, and the expert will type in the Notepad or TextPad their first and last name, save it to the desktop. The expert will then go to the user's internet browser, whether it be Firefox or wherever you want to go, and set the home page to rockvalleycollege.edu. If you don't know how to do that, figure it out. It's pretty simple. Set their home page to rockvalleycollege.edu, and then you'll end the session. When both of you are done, when that's all done, you're going to send to the Dropbox for week 8, put the title Remote Lab, and give me your experience of working with TeamViewer and how you could use this in your life. Okay? Make sense? So now you get to talk to each other and get each other's email, find out when you're going to do this, and then between now, today's Thursday, I'm going to give you between now and next Thursday to complete it. An entire week. All right? Sound good? Easy enough? So go ahead and get with each other real quick. Start conversing. If you need somebody, if you're on a road with nobody, look behind you and say, hey, help me out.
What exactly are we sending to the Dropbox?
Do what now?
What exactly are we sending?
You're sending this information. Describe your experience using TeamViewer and how you could use it in the future.
We're just describing our experience.
Yeah. So yeah, it went great. Maybe I could use it to connect to my mom's computer or at work.
Confidential information.
Yeah, exactly. Yeah. No hacking during the session, by the way. No hacking. And no sending it to any other website besides rockvalleycollege.edu.